Welcome to this web lecture on formulating mixed integer linear programs. In a previous web lecture, we've been looking into what integer decisions are, and now we're going to introduce them into linear programs, which brings us eventually to so-called mixed integer linear programs. So the example that we're going to use is the example of container-based transport. So we have a barge that ships 20 or 40-foot containers at revenues of 100 or 150 euros per item from Antwerp to Rotterdam. The total capacity is 40 20-feet equivalent containers, and loading a 20-foot containers is just a teeny tiny bit faster than loading a 40-foot container, which of course gives us some trade-off here. So if we formalize this, then we have a barge that transports different indivisible goods from K and K at revenues RK from Antwerp to Rotterdam. The important part is they're indivisible, so we cannot transport half a container. We have a total capacity of U, and we have a loading time constraint that tells us loading one item of good K takes TK minutes. In total, the barge must be turned over within a time capital T. So what we're always doing if we see a mixed integer linear program or a linear program, is we identify the sets, we identify the parameters, we introduce the decision variables, we formulate the constraints, and we formulate the objective function. What we're doing in this case here is we're just slightly adapting. So we're reusing the linear program that we developed in a previous web lecture, and now we're just going to tweak it a little bit. So what we previously saw is the sets, commodities, a type of commodities, K and K, which is then, for instance, coal and sand. But now, of course, K is, for instance, 20 feet and 40 feet equivalent containers. Then we have our parameters, revenue, barge capacity, loading time, and turnover time, and they stay the same. Lastly, we have variables, the amount shipped per commodity, xk, for all K and K, but this is now no longer the amount shipped per commodity, but it's the number of containers or the number of items of commodity K. So we slightly vary the definition of our variable, but other than that, it stays the same. Now we also have our constraints. So we still, of course, don't want to exceed the capacity. We don't want to all of a sudden ship 50 containers instead of 40. We also still want to be able to load everything within the turnover time. And we also don't want negative shipment volumes. But in addition to not wanting negative shipment volumes, we also don't want any shipment volumes which is, for instance, 0.5 containers. So we also have xk needs to be in the natural numbers including 0. So 0, 1, 2, 3, etc. Our objective function still remains maximizing the shipment revenues, so nothing changes here. What I would like you to take away from this web lecture on modeling mixed integer linear programs is, first of all, how to adapt a formulation, not always starting with reinventing the wheel, but seeing, is there something that actually looks rather similar? Can I reuse this? If I can reuse this, then I'm adapting the formulation rather than rebuilding everything from scratch. And the second thing that I would like you to take away is what an integer decision variable is and how to define an integer decision variable. Thanks.